Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 4, RK Bali navigation book. This is the 4th edition book. In the previous video lectures, I have answered the first 40 questions from this particular paper. In this particular video lecture, I am going to answer the next 10 questions starting from question 31 to question number 40. So let's begin. Correction, question 41 to question 50. Now question 41. The planned departure time from the parking area is 1815 UTC. The takeoff time is 1825 UTC. IFR flight plan must be filed with ATC at the latest at what time? So always your IFR flight plan must be filed at least 60 minutes before departure time. Before departure time. Now in this question we have been given two times. One is departure time and the second is takeoff time. So your IFR flight plan depends on your departure time, not the takeoff time. Okay, so 60 minutes before departure time. Now departure time is 1815 UTC. So 60 minutes before 1815 means 1815 118 hours 15 minutes in your scientific calculator minus 0 hour or minus 0 hour 60 minutes. So that will give you an answer 17 hour 15 minutes. So option Bravo is the correct answer. Very important question. 42. Aircraft is at a particular position. It flies 0900. That means it's flying a Rumline track easterly direction for 315 kilometers. On completion of the flight, what will be the new longitude? Correct? So for Rumline's formula or Rumline questions, you can draw this particular picture of the Earth from the top of the North Pole, prime meridian, 180 east and west anti-meridian, 90 east longitude, 90 west longitude. Okay. So initial location 60 north, 5 degree west. So this is your 5 degree west longitude and you are flying easterly. Now all easterly directions are anti-clockwise. All easterly directions are anti-clockwise. So you are going from this initial position to a new position which is to the east of it. It can be in the same hemisphere as the western hemisphere or it can be in the new hemisphere, that is eastern hemisphere. So we can check that when we come to know our D long, difference in longitude. Now distance equals to D long in minutes into cos lat. Now Rumline distance here is 315 kilometers. So 315 divided by 1.85 is 170 nautical miles. D long in minutes into cos of 60 degree. So D long in minutes equals to 170 divided by cos 60, that is equal to 340 minutes. 340 minutes is 5 degree 40 minutes easterly. 5 degree 40 minutes. So D long is 5 degree 40 minutes. Now the D long between prime meridian 0 degree and your initial location 5 degree west is, this D long is 5 degree. But the D long that we have found is 5 degree 40 minutes. So additional 40 minutes will be traveled in the eastern hemisphere. Okay, another 40 minutes will be traveled in the eastern hemisphere. So your new location will be 40 minutes east. 40 minutes east. Okay, so option Charlie will be the correct answer. Next, question 43. Isogonals are lines of equal Deviation, variation, velocity. So it is variation. Isogonal lines are lines joining places of equal variation. Next. Indicated airspeed, flight level, outside temperature is given. What is TAS? So let's use CX3. Okay. So outside air temperature is 20 degrees Celsius. So make sure the temperature unit is Celsius 20. Calibrated airspeed or indicated airspeed is 120 knots. Pressure altitude is 8,000 feet. Okay, double check. Pressure altitude 8,000, outside temperature 20, and speed 120 knots. So task will be 140 knots. Okay, so correct answer is option alpha. Next, 45. Elevation airport is given, QNH is given. What is pressure altitude of this airport? So do watch my altimetry playlist in which I have solved all the altimetry questions from Oxford Met book, and I have also explained altimetry, function of altimeter, altimetry errors, density, altitude. Okay. Now let's say this is your airport. The elevation of this airport is with respect to QNH, mean sea level. QNH is 988. Elevation is 1000 feet. Now, pressure altitude of this airport is to be found. Pressure altitude is always measured from standard pressure setting datum 1013. Now, standard pressure setting datum 1013 will be below this QNH datum 988 because 1013 is more than 988. So, as you go down to into the center of the earth or into the earth, the atmospheric pressure increases. When you go away from the center of the earth, that is, as you climb higher and higher from the earth, the atmospheric pressure decreases. But when you go inside in the earth, pressure increases. So 1013 should be found or will be below this level, below this 988 level. Okay. So let's say this is your standard pressure setting datum 1013. Now pressure altitude is to be measured from this datum 1013. Now this pressure altitude is nothing but your elevation, this elevation, right, plus this height, plus the height between these two pressure levels. Correct? Now we know the difference between these two pressure levels 1013, 988. So the difference between them is 25 millibars. Now 1 millibar of pressure difference is equal to 27 feet of height difference. So 25 millibar of pressure difference will be how many how much height difference? It will be 25 into 27, that is 675. So height difference will be 675. Correct? So now pressure altitude will be how much? It will be elevation plus 675, that is 1675 or approximately bravo 1680 feet. 46. Halfway between 2 points, the navigation log gives the following information: TAS 360, winds, compass heading, deviation, variation. What is the average ground speed for this leg? So we are going to use CX3. Now, true, variation, magnetic deviation, compass. The compass heading given to us is 237. Deviation given is -5. -5 is 5 degree west. So when deviation is west, compass is going to be best. Compass direction going to be more than magnetic direction. So magnetic will be less than compass by 5. So 237 minus 5 is 232. Variation is 19 west. Again, variation west, magnetic best. Magnetic to be more than true direction. So true will be less than magnetic. So 232 minus 19 is 213. So true heading 213, winds 330 degree true at 80 knots, dash 360 knots. So let's substitute these values, or let's insert these values in the CX3. Wind correction, dash 360, winds 80 330, and true heading 213. True heading 213. So you get a true course of 203 and ground speed 402.68 or 403 knots. So option A is the closest option. Option A is the closest option, or that is the correct answer. Okay. Next, question 47. A gyro which does not have a rotor, that means a gyro which does not have any physical moving part, is called what kind of a gyro? So that will be a ring laser gyro. 48. The north magnetic pole is at the north end of Earth's axis of rotation, is always in the same position, is slowly and constantly changing its position. So correct answer is the north magnetic pole is constantly moving. Okay, its position is not fixed. It keeps moving around the north pole, around the geographic north pole. Sometimes it can be to the east of it, so we say variation east. Sometimes it can be west of it, we say variation west. Question 49. QFE is so and so. What is the pressure altitude of the field? Very important. So QFE, that means aerodrome level pressure. Atmospheric pressure existing at aerodrome. Okay, aerodrome surface. So let's say this is your airport. Okay, and here the pressure here is 1022. 1022. We have to find pressure altitude. Now pressure altitude is always measured from standard pressure setting datum 1013. Now I have said this before in the previous question just now, that when you go to higher and higher altitudes, atmospheric pressure decreases. When you go to lower and lower altitudes towards the center of the earth, your atmospheric pressure goes on increasing. Now standard pressure setting datum 1013 is less than 1022. So it is, so that means this pressure level 1013 will be found above 1022, because when you go to higher altitudes, atmospheric pressure decreases. So I'm going to draw standard pressure setting datum 1013 above QFE 1022 pressure level. Now pressure altitude is to be found. So pressure altitude will be measured from this datum 1013 downwards. Okay, because airport is below this pressure level. Okay, so the whatever value you get, it will be negative, because measurement is happening, or the measurement that we are doing is downward measurement. So now pressure difference between these two pressure levels is 1022 minus 1013, 9 millibars. That is equivalent to a height difference of 9 into 30, approximately 270 feet, where 1 millibar equals to 30 feet. Right? So answer is minus 270 feet mean sea level. So below, so minus means below. So 270 feet below standard pressure setting data. Question 50. The primary factor which makes the servo assisted altimeter more accurate than a simple sensitive pressure altimeter is a subscale logarithmic function, induction pick-off device, more effective temperature compensating leaf spills. So a normal, okay, conventional simple pressure altimeter has moving parts, okay, and this moving parts will be subject to friction. And whenever friction is there among different moving parts, whatever indication is shown by the altimeter, it suffers some kind of lag, okay, some kind of a delay. But when you use technology, when you include or insert technology in this altimeter, like a servo assisted altimeter uses an induction pick-off device, okay, some kind of electricity in its operation. So efficiency of this altimeter increases. The reading given by it is more accurate. It happens very quickly, instantly. Okay, so the primary factor which makes servo-assisted altimeter more accurate than a conventional one is the availability of an induction pick-off device. Okay, so read this altimeter chapter number 5 instruments book from Oxford, servo-assisted altimeters paragraph. So this is how it looks, and you are going to mark these points. These are important for your exam. At high altitude, at high altitude, the changes in pressure corresponding to a given change in height is much smaller than at lower altitude. That means when you climb to higher and higher altitudes, atmospheric pressure decreases. That's okay. But the rate at which it decreases, how fast or how slow it decreases, this rate of atmospheric pressure decrease becomes very slow. Okay, at lower altitudes, atmospheric decrease is very fast. But as you climb to higher altitudes, this decrease is very slow, very, very slow. So so if you operate your flight with a simple altimeter, conventional pressure altimeter, this slow rate of decrease in pressure will be detected very slowly by your altimeter. So any changes in pressure will be shown to you, okay, very slowly. So in order to get rid of this error or this drawback or this shortcoming, we use servo-assisted altimeters, which are capable of indicating even minute slow changes in atmospheric pressure. So with servo assistance, the requisite power is available to overcome resistance with consequently enhanced accuracy. Small movements of the capsules. This point is important. Even small movements of aneroid capsules in a altimeter, that changes will be detected and corresponding changes in vertical distance, height, altitude, flight level, whatever that is, will be shown to you. But if you use a conventional simple altimeter, the small changes in capsules won't be detected or registered by the instrument, and therefore any corresponding change in height or vertical distance won't be shown. So very important question. So Bravo is the answer. So this concludes our lecture. I hope you have understood these 10 questions that I solved in this lecture. They are easy. Make sure you read the theoretical chapters very well, revise them. I have uploaded many lectures on my channel in which I have marked important points from many chapters from Gen Nav, radio, instruments, and uploaded them. So mark those important points uh, and revise those important points again and again. That will save your time. You need not read the entire chapter. Just go through the important points again and again. With this, I thank you for your time. I wish you all the best and I request you all to share this video lecture with your friends who are also preparing for the exam. See you in my next video.